everybody. Thanks for coming. This talk is about the 3 transitions, how we're going to get cross-chain smart wallets that keep users private. My name is Niran Babalola. I'm a software engineer on the base team at Coinbase. So this 3 transitions concept comes from a blog post that Vitalik wrote last year about the changes that are going to have to happen to the Ethereum ecosystem for normal people to be able to use this new financial system that we've promised them. So those 3 transitions are L2 scaling, smart contract wallets, and privacy. So L2 scaling is what we need to make sure that transactions are cheap enough. People can't send transactions on L1 when the fees are super high. Smart contract wallets are needed because right now seed phrases are how people manage their funds, and people are not comfortable with them. They're afraid of them. And then we need privacy because most normal people aren't willing to put their entire financial history up on Etherscan. We need to have a way for them to be private when they're on chain. So we've all kind of experienced this problem with seed phrase wallets about how hard they are to use, especially when you're trying to get a new user on board. First, you have to install an app that's special for your wallet. There are literally 400 you can choose from. I didn't believe this until I actually went through the process and saw the pop-up the other day. It says 400 plus wallets. It's crazy. You have to write down your seed phrase. You can't lose it. It's this magical phrase that doesn't work the same way as anything else that users have ever used. You have to fund your account to pay for gas. If you want to use multiple accounts, you have to put gas money in each one. And then you have to sign multiple transactions to get stuff done. You can't batch anything. You have to do your ERC20 approved, then your transfer. It's just not very great. But luckily, now we're in the world of smart wallets. Smart wallets are here. If you haven't used one, definitely try one. Go to wallet.coinbase.com and try ours out. But those smart wallets solve those problems. You don't have to use seed phrases, and you can batch transactions, and you don't have to pay for your own gas. So the way that we handle configuration changes for a smart wallet is that when you want to add a signer to your smart wallet, that same transaction can be replayed on any chain that you're using. So if you're using 5 different chains and you want to update your signer, you can replay that transaction on those chains. But right now, there's no mechanism to keep those in sync. So it's possible for the configuration to diverge across chains. So you don't really have one wallet that lives on multiple chains. You have one wallet per chain that might have a different configuration from the others. And that's not the experience that we want users to have when they're using these wallets. So there's no eventual consistency. They can diverge over time. When it comes time to develop new features, like session keys that people were working on recently, the replay feature is specific to signer changes. So if there's other configuration that you need to add to your wallet, you have to build another process to be able to replay those changes across chains. And that's just kind of a mess. It would be nice if there was a way to do more kinds of configuration at once. And lastly, every wallet vendor has to build this functionality themselves. If you want to be a vendor of a wallet that uses smart wallets and keeps them in sync across chains, there's a huge engineering lift to make that happen. It would be nice if there was a common set of tools that wallet vendors could use for their smart wallets to stay in sync. So Vitalik's vision for this has been key store wallets. Key store wallets, instead of writing your configuration for a wallet directly in the storage of the smart contract on each chain, what key store wallets do is have a key store that's the single source of truth for your wallet's configuration. And then all your wallet contracts on every chain are pointing to that same key store to be able to read the configuration from that place. So there are 3 blog posts that Vitalik has written about this. One is, 2 of them are from last year, and then there was one a couple of weeks ago as part of that Futures of Ethereum blog series that you can read. And there have been several teams that have been pushing forward this concept over time, Safe Wallet, Scroll, Stacker, and others. And on the base team, what we've been working on is Keyspace. Keyspace is a key store for cross-chain smart wallets that keeps their configuration in sync. It's an implementation of this key store wallet model that's specifically designed to address the problems that we run into with the Coinbase smart wallet. So the way you use Keyspace is first you give your smart wallet a key store. So the way to think of how your key store lives in this model, it's not a separate thing for your wallet and Keyspace. Your key store is built into your wallet and Keyspace. So your smart wallet contract literally inherits from this key store to be able to gain the functionality to write the configuration locally and sync it across chains that's built into your wallet. So you deploy your wallet on 1 chain, 2 chains, as many chains as you want. One of those chains is the master chain, the source of truth for your wallet's configuration. The other chains are replica chains that are syncing configuration from that master chain. So when you make a change to your signer configuration, you're writing it directly to the master chain, and on your replicas, you're syncing from the master chain. So the approach that we've taken uses general purpose L2s as the master chain for your wallet. And that's, there are other designs out there. One of them has a dedicated L2 just for key stores specifically. So the path that we've chosen is cheaper. The transactions are cheaper. It's easier. We don't have to build a specific rollup from scratch. But the downsides are that it finalizes more slowly, and it involves more moving parts if you're using a general purpose L2 for this purpose. So a lot of the issues that I'll talk through are how we've gotten over those hurdles to make it usable. So as a wallet vendor, when you're integrating a key store into your wallet, you need to choose which chain is going to be the master chain for your wallet. We don't expect that every wallet vendor is going to want to use Base as the master chain for their wallet. In fact, many wallet vendors have their own L2s. That seems to be an emerging trend, and we expect that they're going to want to use their own L2 as the master chain for their wallet. So right now, Keyspace has a built-in support for OP stack chains to be the master chain. So any OP stack chain can already use it out of the box, but it's also pluggable. So if there's another stack that your wallet, for the master chain that your wallet wants to use, we want to help you with your pull request to get that functionality in there to be able to use your stack as the master chain for a key store wallet. So you've deployed your wallet to all these chains. You started using them with your initial configuration, but then you eventually got to this point where you got a new phone and you want to add a signer to be able to access your wallet from that phone. So now you need to update your configuration. And what that looks like behind the scenes is you're signing a hash of the new configuration, and you're setting that as the new configuration on the master chain. So there are hooks that your wallet contract needs to implement to be able to handle each stage of the process. The first one is authorizing the new configuration update. So typically it's just checking the signature and making sure that it's signed by one of the signers in the previous configuration. And if so, the new configuration is authorized. After that happens, the key store itself does its own bookkeeping because it needs to store that hash of your configuration. That's what's being synced across chains. We're not syncing your whole configuration, we're syncing the hash, and you're doing the syncing of the configuration at the end of the day in the client. So once that's stored, the wallet can then apply that new configuration to its own storage. The user has provided a new configuration that gets handed over to the wallet to write to its local storage on the master chain and on the replicas. So you don't have to change how your wallet stores data necessarily to be able to use Keyspace. You're going to get a payload from Keyspace to be able to write to whatever storage format you want to use. So there are minimal changes that happen to the logic in your actual smart contract when you're using this. Lastly, there's a hook to validate the new configuration. And this is important because if you think about the way that most smart wallets work, typically there's a function to add a signer, a function to remove a signer. There are these specific atomic actions that you're taking when you're changing the configuration of a wallet. But with the key store wallet, you're not just changing a signer, you're swapping out an old configuration and putting in a new configuration. There's so much more that can change, and there's so much more wiggle room for something to potentially go wrong. So this validate hook is there for you to be able to verify that the new configuration can actually verify the signatures that it's supposed to be able to. And if it can't, you can revert to make sure that you don't apply an invalid update. But if it can, you know that you've done a successful update and things are good to go. So once you've updated your configuration on the master chain, you might want to use your configuration on a replica. So the way that Keyspace works is that it's eventually consistent. Each wallet vendor can determine how often they want to require their users to sync their configuration from the master chain. And a lot of the examples that we use, we just choose 7 days as an example, but you can choose anything you want. And our TypeScript library for wallet clients allows you to generate the cross-chain Merkle proofs that you need to verify that your key store on the master chain, to verify the state of your key store on the master chain to any replica that you want to prove it to. So again, since we're using general purpose L2s as the master chain in the system, these are, a lot of them are optimistic rollups that take a long time to actually finalize, 3.5 days to 10 days if there's a challenge. So the data that you're syncing from the master chain to the replica isn't necessarily that latest thing, that new signer you added, it's the state from 3.5 days ago. So when you're actually trying to use that new configuration immediately, what the wallet client does is pre-confirms that change on the replica chain that the user wants to use. So imagine that your wallet's master chain is Base, and your user wants to send a transaction on Optimism. So they set the new configuration on Base. That's going to take 3.5 days to get to Optimism. So literally, you take that same payload that you executed on Base, and you execute it on Optimism to make a local change of the configuration on that chain. The way to think about what the syncing is doing for you is not that it's providing the latest data on every chain for you to use. It's really coming behind you. It's making sure that the local state changes that you've applied don't diverge from the state of the master chain. So imagine you have a chain of 4 configuration updates you've made on a chain. As it syncs the older data from the master chain, it's going to confirm that those are consistent and allow you to keep using that latest configuration change that you've made. But in the case where something has diverged and it notices that the master chain state is different from what's on the replica, the master chain state is going to overwrite that and take precedence. So one special case here is when the user wants to revoke a signer. Because again, in the normal case, you're adding a signer, you want to pre-confirm it on the chain that you're going to use right now. But if you're revoking a signer, you want that signer revoked on any chain you have assets on as soon as possible because the key might be compromised. So that's a scenario where the wallet client is responsible for helping the user to broadcast that pre-confirmation to every chain they have assets on, to detect when a signer is being removed and to broadcast that pre-confirmation appropriately. So we talked about what happens when you create a wallet and what happens when you update it. When you upgrade a wallet, there are some special cases, as well as when you initialize a wallet on new chains. So when you think about how the proxy implementation contract of a smart wallet interacts with the configuration, they're very much intertwined. The configuration doesn't mean anything without the implementation contract that's reading from it. So if you do an upgrade and you upgrade the implementation contract, but you have an old configuration, things might not work. And if you sync a configuration, but you haven't synced the implementation, then your old implementation might not be able to read your new configuration. So you really need a way to do atomic upgrades of both the configuration and the implementation at the same time, and Keyspace lets you do that. The way you do it is by storing your wallet's implementation address within the key store that gets synced across chains. And when that apply update hook gets called, your wallet can check to see if the implementation address in the contract matches the implementation address in the key store, and if necessary, perform that upgrade. Just like the normal configuration updates, there's that verify hook to make sure you didn't mess things up. Because if you swap out the implementation and you're swapping out the configuration, there are a number of ways that things can go wrong. If you call that verify hook, you can make sure that the signatures you expect to be valid with that new configuration and that new implementation still validate at the end of the day. We also expect that there's going to be many new chains over time. And on every new chain that pops up, you're going to want to be able to claim the address that represents your wallet. But your address is forever tied to the factory that created it in the first place. And the factory that created your wallet is written in 2024, maybe 2025. There's going to be a new chain that pops up in 2030 that you want to use, and that same logic needs to be valid. But every time there's a hard fork of L1 or L2, the cross-chain syncing process is put at risk. L1 can break syncing if they change how the state root works, and they have promised to change how the state root works. The Merkle-Patricia tree is going to become a Verkle tree or something else, and then syncing will no longer work. Likewise, the L2s are going to have hard forks that change the system contracts. The dispute game factory is relatively recently. That change would have broken the syncing. If the system contracts on the L2 itself, like the L1 block contract that we use, if that changes, that would also break syncing. So to make sure that in 2030 you can claim the same address that you want, the eventual consistency requirements do not apply when you are pre-confirming your configuration changes on a chain. It doesn't matter how old your last sync is, you can replay any change you've made in the past on a chain without triggering any syncing requirements. So the way that that helps you out is that on that new chain in 2030, you can take every configuration change that you've played on the master chain. You can replay it as a confirmation, no syncing, just pre-confirmations. And then once you've synced both a configuration and an implementation that knows how to sync across L2s in the way that is actually valid in 2030, you now can sync and make that happen. So you need to be able to replay those configuration changes to get back up to speed and claim your address on any new chain that pops up. So with Keyspace, wallet vendors can deliver an account for every chain that's as easy to use as off-chain accounts. We need a way to get to usable accounts for normal people if this is actually going to become the new financial system that we onboard people to. But the missing piece still is privacy. How do we make sure that when people start using on-chain systems, that they can have similar privacy to what they have in the existing system, if not better? When it comes to privacy, there are really three levers that we have to pull. One is pseudonymity, where senders and recipients are using as many fresh identities as they can. And if you've used the Bitcoin HD wallet, that's kind of how they work. They're using a new address every time. There's anonymity, where the senders and recipients are completely unknown. The amounts are known, but the senders and the recipients aren't. So that's how Tornado Cash works. You have these different bill sizes, but you don't know who's sending them. And then there's confidentiality, where the transaction amounts are not known, but the sender and recipient are. So you know that Alice is sending something to Bob, you just don't know how much. So these are the levers that we have to play with. And the lever that Keyspace gives us is pseudonymity. Keyspace allows us to bring pseudonymity to Ethereum. Again, when we shifted from this Bitcoin world to this Ethereum world, what was sacrificed was the ability to use many fresh accounts, because you have to fund your account with gas. And if you have tokens or NFTs in your account, you can't send anything with that account. Now that we have smart wallets, we have paymasters that can fund our transactions. So we can have as many smart contract identities as we want. And now that we have Keystore wallets, we can keep those in sync. So you have these as many accounts as you want that use the same signer configuration, so you can use it on any device you want. So the problem is that if you implement that the naive way, where all of your pseudonyms are pointing directly at your Keystore, then you've lost the pseudonymity. Everybody knows that this fresh account is tied to all the other ones. The way you get that back is by using zero-knowledge proofs to make the link between the Keystore and the pseudonym private. So if you imagine what's actually stored in the smart contract of your pseudonym, it's not the address of your Keystore wallet anymore. What it is a hash of that address and a random number that nobody else knows. So when somebody else is looking at this wallet, they just see a hash. They don't know who this wallet belongs to. And the way you send a transaction from the pseudonym wallet is by generating a zero-knowledge proof of your Keystore address, that random number that you generated, the same cross-chain Merkle proof that proves the state of your Keystore, so you know which signers are valid, and then the signature that's used to actually authorize the transaction at the end of the day. Those are all private inputs to a ZK snark that you're sending with your transaction. So the link between your Keystore and your pseudonym are never exposed to the public. All your pseudonyms are usable by the same Keystore, usable with the same passkeys on all the devices you have, but nobody else knows what they are. So what that gives us is access to kind of a sweet spot of privacy for Ethereum. If you have pseudonymity and confidentiality, we can end this world where you look up somebody's Etherscan page and you see all their financial history since 2015. Instead, you can have pseudonymity from Keyspace, which allows you to create as many accounts as you want and use them for each new transaction. And then you can have confidential ERC20s, which use fully fully homomorphic encryption to hide the amounts that are being sent in each transaction. And if you combine both of those, obscuring the sender and the recipient and hiding the amounts that are being sent, users can now have privacy for the transactions that they're sending. So the Keyspace team is me, Baptiste, and Michael at Coinbase. And we want you to reach out to us. The documentation is up at docs.key.space. If you look at that right now, that will be outdated. But if you look at it a month from now, that will match what I've said here. But definitely excited to answer any questions that you have.
All right, good stuff. Awesome. So we got some Q&A, some questions before we go on to the next talk. The first question was, how is this private? I think you answered that in the last few slides. That question came up early. But the next question asked, actually just came right up to the top. Isn't pseudonymity just Ethereum?
So yes and no. Right now, the common practice for users using Ethereum is to use the same account over and over and over again. And that includes the ENS names that they use. So if you have Vitalik.eth, you used to have a pseudonym that was your address, but now you've told everybody who you are, and that's what most of us do when we use these systems. It's hard to manage many addresses. Each time you create a new address, you do have a new pseudonym, but because it's typically an EOA account, you have to fund that with gas, and it's just hard to, and you can't change the keys. So it's really adding the ability to create as many pseudonyms as you want, funded by paymasters because it's a smart wallet, and with configurable signers, so you can use it on any device you want.
Cool. I think the next one is, if we provide the same payload on Optimism for Base without waiting for the period of 3 days, potentially allows for a replay attack again, right? What problem is this solving?
So it's not that there's well, I'm not sure what replay attack you're referring to, but really the idea is that your configuration for your wallet is something that you actually want to apply to as many chains as possible. So if you update your configuration on Base and you take that same payload and you play it on Optimism, that was your desired outcome. That's not something that you didn't want to happen. You wanted all your wallets to stay in sync. So it's not, what it's giving you is making sure that after a certain period of time, all your wallets will be in sync. They never diverge permanently because there's a point in time, that 7-day window, when you'll have to sync and your wallets are guaranteed to not permanently diverge from each other. You can have that experience of having a single wallet on many chains rather than one wallet on each chain.
Cool. Oh, this bumped right up to the top just now. Does this only work on EVM-based change? What if it would be worked like on Tron or Ton, and they're asking about L1s, but also I'm going to extend this, what about L2s that are alt VMs, like Eclipse and Movement?
So this can work anywhere you have a virtual machine. So again, you won't get the same address because it's using a different virtual machine. You'll have to use a different factory to create your wallets. But anywhere you can verify a proof of the state of the key store and verify that against the L1 block hash, you can use the same key store. You could use it on Solana if you wanted to. The problem there is that once you are outside of the rollup world, you now don't have a trustless source of the L1 block hash to do those proofs against. So it does get trickier. You do have to make more trust assumptions about what's happening. But if you want to use the key store outside of the Ethereum ecosystem, you can use it anywhere you want and keep those in sync.
Cool. So when do you expect the Coinbase Smart Wallet will use Keyspace? Will it be a simple upgrade to existing users?
Early 2025. That's it will be a simple upgrade for existing users. That's what we're designing for.
Great to hear. How do you deal with reorgs on specific chains?
So when there's a reorg, your wallet configuration updates do not depend specifically on chain state outside your wallet. So if you think of your configuration as having its own nonce that is upgraded with every new change you make, if there's a reorg, the transaction can just be played again and it will work. There's no state you can get into where you now have incompatible states of your wallet because, again, the master chain is the source of truth. If you prove something wrong across chains that ends up rolling back later, it's whatever was on the master chain that's going to be the final value. So if there's, okay, so in the case where there's a temporary reorg, you sync from the master chain, but now the master chain says something different from what it did before. When you do your next sync, whatever's on the master chain is going to blow away whatever you have locally. So that's how reorgs are handled.
All right, everyone applaud for Niran. Great talk on keys and wallets. Our next talk.